All right, welcome again. It's Mr. S for my AP Calculus Period 2. The last video we stopped here. Okay, you want to see how to find the area between all these jiggly lines. Go back and look at it. All right. And again, the music in the back is just some Hawaiian theme song, so we'll keep that going. Keep it soft. All right, here we go. The first thing you have to know about all these rectangles is it right rectangle approximation method, left rectangle approximation method, or the midpoint? So here are the differences. The left one means the left side of your rectangle is touching the curve. Okay, this is just easy sample equations from the y equals x squared. All right, so they divide things up into like 5 different rectangles. Now this, to me, it looks like they got the midpoint of your top touching that line. So that's the MRAM. The last picture here is the right side of your rectangle is touching that curve. So this is your left touching the curve, middle touching the curve, and the right side of the rectangle is touching the curve. So what that means is you're going to get the right side being the height, and the width here is your base. So base times height will be your area here. Not all the time that they're going to be under and over estimates. For some of you guys that are paying attention here, there's some gaps here while there's some extending portion on the rectangle. So to me, this is the right end rectangular, but if the curve is going up, I would be overestimating. If the curve is going up and I'm using the left end approximation, I will be underestimate. So you're gonna be seeing those later, okay? So just kind of make a mention on that. Which way is better? Well, if you divide them all up into smaller pieces, they're equally as good. All right, let's move on. So just another idea on the left end, right end kind of thing. So this is the left end approximation method, right? So initially I will have my rectangle going this way first. So my rectangle is like that. So this is the left corner. What I would do is I'm going to extend this left corner and make it touch that black line there, the f of x function. So now I will have this as my left corner. So it's called the left end approximation. Now the middle, again, so right now the left side is 90 units, right? So on the midpoint, you're gonna pull this all the way until your midpoint right there is touching the curve. Okay, somewhere there, close enough. So this would be your midpoint touching the curve. So it's called the middle or midpoint approximation method. So what you're doing is you have to find this location, which to me right now should be 1.5, right? To find that height, by the way. So this point is 1.5. Then if you have some kind of random function, f of x, then you plug in your 1.5 in that function, you can calculate that height there, okay? So here you follow the left end, so your x is 0. So you plug a 0 into your f of x, you should be able to find the height there, but that one should be easy. Now let's talk about the, because it's 90, I'm sorry. All right, I'm using my mouse to write that one. Okay, so that f of x should be 90. Now this last one, I'm gonna do the right rectangle, or right side of the rectangle, touching that curve. So there you go. I should be like that. Notice the curve when it's coming down, when I use my right side, it should be underestimate because I have a gap in the top. When the curve is going up, watch this. If I follow this and pull the right side up, I'm overestimating. Okay, and same here. If I went with the red box here and I pull it until the right side touches the curve, notice that I get that extended part. So that is overestimating. Okay, if I go when the curve is coming down, let's see. So if I bring the red one over here to the curve when the curve is coming down, see my right side is touching already, but I have a lot of gaps up here, so I'm underestimating. All right. Last discussion was I pull this up and touch the curve. So that means I will find that height on the right side of my rectangle. Here's my width of 1. Then I just plug in my f of 3. And again, those x number down here, so on your midpoint, that should be 1.5, okay? So f of 3, you plug it in, you do the calculation, you get the height. So each height will be different based on the location of your axis. Let's move on and do some real problems. So hopefully I can do it under 10 minutes. So here's a function f of x equals x squared, just like the first picture you saw earlier. So here I'm going to do my right-in approximation, okay, according to this. And I'm doing 4 rectangles, all right? So 4 rectangle right in. Let's calculate the first one. I'm going up there, touching that side. So now, I'm not quite getting the bottom of that, just visualizing it. Okay, so now to find the first rectangle, I'm going to call it the R1, or rect number 1. That should be the base, which is, now if this is 1 to 2, here's your 1.5. So right here should be 1.25, okay? So now, because the base here would be 0.25, 0.5, 0.75, and 2. So it should be 1.25, 1.5, 1.75. Those are the x's, but the width is 0.5 each. So make sure you understand that part. So it's 0.25 each, I'm sorry. So now you're going to time it with the f of 1.25. Why is it 1.25? Because that's the location you're going to get the height from. So now you take your 1.25 and plug it in here. We can do that on a calculator, okay? So it's just 1.25 squared. Then follow the next rectangle. I'll call it rectangle number 2. And the width here would be 0.25 again, okay? Sorry if I did say 0.5, it's not 0.5. Now this time we're going to time it with the height. Oh, I didn't pull the height yet, so let me pull the height up here. I might want to erase some of these little junk here. Okay, it looks too messy. So let me drag this blue one, and then I'm going to drag it until the right side of my blue box touching the f of x. So right now I'm going to say, well, the width is still 0.25, the base times the height, right? So now I'm going to do 0.25 times that height. That height would be, this spot right here is 1.5. So I'm going to times it by f of 1.5. What that really means is you're going to take your 1.5 and plug it in there, and then times it by 0.25. And we'll repeat for the next 2, okay? The next 2 triangles. So rectangle number 3, 0.25 times f of, this time should be 1.75, because each distance goes up by 0.25. Last one, even without pulling my rectangle, right? So I forgot to pull the rectangle here. Some of you guys would, hey, wait. It doesn't really matter, but okay. So that should be that height there. Here would be pulling the rectangle and my last height at 2. Okay, the last height should be at 2. It's going to plug into my f of x. Okay, I'll just write like this. I can do all that in my head, not all of it, but close to. So plug in a 2. So that's what that means. So 2 will go square, 1.75 will go square, 0.5 will go square up there, and then 1.25 will go square up there, and then you multiply each one by 25. Now, if you know how to factor, we can deal with that in the next video. So we'll just do the calculation and get the answer for this. Okay? So let's see. You can type them all straight in there now, or you can do this here. So let's see if you can see my calculator. You can sort of see it. Okay, yeah. Get some angle there. So now you can do this. 1.25 square plus, right, 0.5 square. Now there's a lot of different ways to do it. 1.75 square plus 2 square. Now what I did there is I got all the square terms, all the functions calculated, and add them all up and multiply it all by 0.25. Okay. You can do it one by one. So that's the area between 1 to 2 under the curve of x equals and y equals x squared. From 1 to 2, I have 4 rectangles calculated based on the right end of my rectangle. Okay, so just write that number down and you're in. That's it. Okay, so the area here would be 2.71875. All right. I'll see you in the next video.